Welcome to day 2 of our conference, and as you know, this morning we have a special guest speaker who is, I've heard speak and is a terrifically appropriate for our cause, and I'm not going to introduce him, so I don't want to say anything about that. Just one housekeeping detail. Those of you who have food and beverage and snacks in your hand, I've been asked to tell you by Kevin, who is the arbiter of all things cool, that you are street legal. You may eat in this room. You may drink in this room, and please recycle your crumbs. Is that close enough?
There you go.
All right. So let's get going.
Hi, I'm Claudia Hase. I am a postdoc working with Bob Levinson at the Institute of Rationality in Social Research at the Department of Psychology at UC Berkeley, and I'm a member of the BCRN. I am a developmental psychologist, and I am interested in what makes people happy and healthy and productive or miserable and sick. And it's my great pleasure to introduce our first speaker. And for those of you who were here yesterday, you all know him, Shachar Kariv, our very own Shachar from the Department of Economics at UC Berkeley. For those of you who are joining us today, Andrew Kaplan, our speaker who we originally had planned, couldn't make it because of the storm in New York. So we are very happy to have Shachar here with us. He's at the Department of Economics and the X Lab at the University of California, Berkeley, and he is going to tell us about who is more rational. So please join me in welcoming Dr. Shachar Kariv. Thanks.
Will change. Okay, so first, thank you. Andy Kaplan was one of my PhD advisors, so it's a great honor substituting for him. And I am going to talk, if I'm able to get this thing straight here. Let me also use technology. I am going to talk about who is more rational. Oh, yeah. Sorry. So I'm going to talk about who is more rational, and it's a research agenda with these three fine gentlemen. Doesn't work, never mind. Okay, so let me start by making a few confessions that actually was hard for me at least to digest. So I think that now, even I think that there is actually a gap between what people actually choose and what they would choose if they were fully attentive to their choices and had the skills or knowledge necessary to weigh cost and benefits. Especially if we are talking about decisions that are complicated, lifetime decisions like, lifetime decisions like how much I should save for retirement or different complicated financial decisions. And we have data showing us that even people that are highly educated, they have very low level of basic financial knowledge. There is a decline in this knowledge and in more basic cognitive functioning with age. And there is definitely, when we come from economy, from the perspective of economics, there is evidence of decisions that clearly leave money on the table. And I think that now many people in economics agree that even if people had all relevant information, they might not have the ability to identify and make the choice that best meets their long-run objectives in what is today's complex settings. And this has led some economists to be therapists. And this is what is called the economist as a therapist, and this is called the libertarian paternalism, asymmetric paternalism, or light paternalism, but it's all pretty much the same. What is light paternalism? Light paternalism is not in contrast to hard paternalism, which is basically a law. You need to put a seatbelt. Light paternalism is a policy that is selected with the goal of influencing the choices of affected individuals in a way that will make those parties better off. And most importantly, is to steer human behavior in more beneficial directions while basically minimizing how much we are intervening with their choices, maintaining their individual autonomy over their decisions, and maximizing choices to the greatest possible extent. So there is a problem here. And the main problems that face people that want to use light paternalistic policies are problems that I discussed yesterday, and this is the problems of measurement and identification. So in some cases, I would say in very few cases, the relevant incentives are so clear and the data and the quality of the data is sufficiently high, so regarding some decision is low quality is really straightforward and unconventional. What typically people will get in economics? People will get in economics data from, let's say, a particular credit card. And if you see that I have balances on this credit card, and then I'm using this credit card to make purchases, this is, as we know, this is definitely a low quality decision. But what's the problem? The problem here that the researcher only has one credit card and he doesn't know what happens with my other credit cards, for example. So you only get a slice of my financial decisions. And even more generally, it's more than data, a measure of decision-making quality, basically saying this decision is low quality and this decision is high quality, is very difficult to formalize, to quantify, and to make practical in a variety of environments and domain. And this feature, I think, that it's basically practical and portable between domain for economists, as you might suspect, is especially important to the extent that decision-making quality is a character of a human being. There are some people that have high decision-making abilities and other people that have low decision-making abilities. And we are basically after this question. So let me be more specific about it. I think that economists will now say that a heterogeneity in decision-making quality, again, a decision-making quality is a character of a decision. Decision-making ability is a character of a human being. So I agree. I think that economists will be very open to the idea that people, everything comes in different levels in human beings. So some of us are good golf players, others are not. So I think that some of us are good decision makers and others are not. So I think that this has for economists an intuitive appeal and very important consequences. However, in order to make judgment about the quality of decision making, we have to solve two problems, which I alluded to yesterday. The first one, economists like to measure things. So the measurement problem is to define, theoretically, and implement in practice a portable, practical, quantifiable, and an interpretable measure of decision-making quality. And when I'm saying that we can interpret it, economists will mean basically how much money you leave on the table because you are making bad choices, low-quality choices. And finally, like anything in economics, there is an identification problem. I really don't know why you do what you do. So the heterogeneity in choices can either come from heterogeneity in preferences, from information, from beliefs, or constraints. So, if you see that Bob bought a BMW and I bought a Honda Civic, it might be that because Bob loves cars and I don't. It might be that because Bob has more money and I don't. It might be that Bob is more knowledgeable, he has more information about cars, and it might be that actually we form very different beliefs. He thinks that having a BMW will change his life, and I don't, okay? On top of it, it might be that Bob is a good decision maker or high ability decision maker, and I'm a low ability decision maker, okay? So I think that the important question for economists, okay, so what? Why should we actually solve the measurement problem and the identification problem? So I think my first point will come just from moral grounds. I think that if you tell me that Bob's bad decisions are because that he's a low-quality decision maker, I think that then actually light paternalism, I think, is justifiable. But if you tell me that Bob's decision is bad because these are his preferences, I think that light paternalism is less acceptable. You know, it's one thing I help Bob to achieve his goals, or I intervene and I'm actually trying to cause Bob to change his preferences. And secondly, I think many welfare conclusions that we are actually making, like for example, let me be a bit maybe provocative, that smoking is bad for you, are wrong. You know, if I jump from airplanes and I'm having a very risky lifestyle and this is what I like, and I'll probably die very shortly, let me smoke. You know, I enjoy it. So I think, of course, this is an extreme and silly example, but I really think that in order, all of our welfare conclusions about what is good for you and what is bad for you, I think are sensitive to the identification problem. So what we want to do, we want to compare the relative importance of heterogeneity in decision-making quality, and for this we'll need to solve the measurement problem and the identification problem, and heterogeneity in preferences for predicting important economic outcomes. In this talk, I will just talk about important economic outcomes, but we are in the process of basically also evaluating other outcomes like health outcomes. Okay? So let me just give you an overview of things that I will explain later. So what people are doing to date. So in order to solve the measurement and identification problem, people are aware of it. And here is basically the solution that was proposed by Lowenstein in a couple of papers. And he says, even light paternalistic policies should only be put into play when the welfare judgments tends to be relatively straightforward. So my position on this never happens. It's never straightforward. However, here is according to George when it is straightforward. It is straightforward when you can observe people are making strictly dominated actions. I really don't know how you can observe it in practice, and it really requires some moral judgment what is dominated. Decisions that clearly lead to negative outcomes. You know, define a negative outcome to me, and this is what I disagree the most, I would say, choices that are not in line with stated preferences. So I tell you that I quit smoking, and that I want to quit smoking, and I don't, which makes smoking bad. This is the most difficult statement for me to digest. And the example that they put include contributing less than the 401k match threshold. So this is true. This is really leaving money on the table. But you know, I might not do it, not because that I'm a low-quality decision maker. Maybe it's constraints. I really need the money now. Maybe it's preferences. I really don't care about my retirement. It can be many other things. Another example is filing for Chapter 13 bankruptcy. This is, of course, this is a bad economic decision to do this. But, you know, sometimes you are forced to do this. And wanting to get out of debt, but failing to do so. You know, again, it has to be with constraints and many other things. So I want to go back to our founding fathers, and who I think is the most important economist of the 20th century, Paul Samuelson. And in 1947, he basically published a book called The Foundations of Economic Analysis. And what is interesting about this book, that it's going exactly the opposite direction than we went. You know, what we assume is that people have some objective function, which we call a utility function, and that they are maximizing it. Samuelson went exactly the other way. He said, if you give me a set of data, can I have a test whether people are maximizing anything? So we are basically going to adapt Samuelson's approach, and we are going to say that choices are of low quality if there is no function that choices maximize. So you have to be careful here. I'm not saying that in order to be rational or that choices are of high quality, you need to maximize a particular function. You need to maximize any function. But when you maximize a function, I'm not going to question you whether it's the right function or the wrong function. Now, it's important to understand that this is a black box, and I can put more restrictions. But what we claim here, this is a necessary requirement. Maybe it's not sufficient. For example, in the domain of decisions under uncertainty, under risk, we are always thinking that people are maximizing some objective function, and sometimes people are thinking about rationality as expected utility. So this is basically already restriction the type of functions that we are talking about. I'm not going to do this, but we can do it. But what I claim here is if I see a set of choices that you took, and there is no function that, that you maximize, no function at all, and I will have a very strong test to do it, I will basically say that you are not being purposeful. Okay, so Samuelson and others basically developed what is called revealed preference theory, and this will provide a direct test. And choices are consistent with maximizing such an objective function if and only if they satisfy what is called the general axiom of revealed preferences. And I will explain it intuitively, what the general axiom of revealed preferences means. And the nice thing about the general axiom of revealed preferences is that it imposes the complete set of conditions implied by utility maximization. And we have a variety of goodness of fit measures that can provide a very strong test of this decision-making quality. And this is basically what we are going to do. So before showing you, let me show you how we are doing this. So basically, okay, I won't move. It's very hard for me not to move, but I won't move. Okay, so this is basically the interface that our subjects see when they are doing the experiment. Let me say that we have this experiment was done now by thousands of people, ranging from undergraduate students to Yale Law School students, to a representative sample of thousands of people in the Netherlands. Now we are moving to a representative sample of thousands of people in the United States. And we also did it in Tanzania, in places where we basically had to come with a laptop and put something on the keyboard because the keyboard was too exciting for our subjects. Okay, so they only moved the mouse. So let me tell you the story that our subjects see. If you came into the lab, you are going to see 50 lines like this. And if you have a little bit background in economics, this is the standard choice in economics. This is what is called a budget line. Now, of course, we don't tell it to subjects. But here is the story. Subjects are coming into the lab, and in the experiments that I will describe today, we are telling them there are two states of nature, Y and X. Y is going to happen with 50% chance, and X is going to happen with 50% chance. Your task is basically to choose a point on the line. You see, by moving the mouse, you can choose a point on the line. And any point on the line, this is not how we explain it to subject, is basically a financial portfolio. What you are buying assets here that are called arrow securities. And what an arrow security tells you, it tells you, I'll pay you $1 if this event happens and nothing otherwise. So for example, this point, what you did, you bought 20.4 securities that will pay you if state X occur, and 39.9 securities that will pay you if state Y occurs. So this is really a financial portfolio. It's a decision under uncertainty. And what happens here is that if state X occurs, you will get, let's say, $20.4, and if state Y occurs, you will get $39.9. So during the course of the experiment, if you see, the X's are labeled from 0 to 100. During the course of the experiment, people will typically get 50 lines like this. The lines are drawn completely at random under one restriction, that at least one intercept is above 50. People will do the experiment without any feedback, and at the end, we are going to choose one round and we are going to pay for it. How much we are going to pay for it? At least such that people on average will make their hourly wage. In economics, you know, we pay you in order to incentivize you to think about the problem. And how much we should pay you? At least your hourly wage. This is what the market tells us. However, when we did this experiment in Tanzania, for example, this was 6 months' salary. Okay, it was a lot of money. Okay, so let me just go over to understand if we understand each other. So suppose that I'm risk neutral. I just want to maximize my expected payoff in this experiment. What should I do? Given that the probabilities are 1/2, 1/2, I should choose the highest intercept. Suppose that on the other end of the extreme, I'm infinitely risk averse. So I should go to the intercept with the 45-degree line because this is like buying full insurance. In general, the more risk averse I am, I should go towards the 45-degree line. If I'm crossing to the other side, I need help. Why? Because I'm leaving money on the table. I'm violating first-order stochastic dominance. Any point on the shorter side of the 45-degree line has another point on the other side that exposes you to the same risk and give you a higher expected return. I'll answer in a minute, okay? Let me just, yeah. Yes.
What is the X handle and the Y handle? That's what I missed.
You know, the computer will just flip a coin, and with 50% chance, it will decide that the state is...
I understand that, but what does the X...
Money, dollars.
I know, but are the tokens equal?
Yes. The token, we say tokens because we want to keep the experimental interface the same when we are moving across environments. So, for example, at Berkeley, with Berkeley undergraduate, a token was equal $1, both X's. Yes. At Yale Law School, a token was equal $5, because this is the difference in hourly wage, okay? Yes, equal. So, let me give you some of the advantages of this technique. So the first advantage is that if you ask me why 50 decisions, why drawn like this, I have a theory to tell you this is what I need. Okay? Unlike survey questions, which we can always debate whether it's the right questions or not. I have a very precise metric to tell you I have enough. Okay? And you know, sometimes we are using 25 decisions, sometimes we are using 150, but we have enough. Secondly, this design is portable for any decision. So what we are doing here are decisions under risk, under uncertainty. But we also did decisions about time preferences. Y is going to be money tomorrow, and X is going to be money today. We also used it in order to study social preferences. Y money for me, X money for someone else. This will be a dictator game with different prices of giving. So because it's the most standard economic decision problem, you can just relabel the goods, and with the same interface, you can do different decisions. So I'll take the question. Let me just go quickly and show you decision. Oh, you see, so you're getting different line. I'm just clicking. You're getting different line. And I can show you individual behaviors later. Yes? That's a great question. I know for sure. Why? Because first I will get a fingerprint of your behavior, and understanding the task for me is that there is an objective function that you maximize. If I get this data in a way that I will show you in a minute, and I know that there is a mathematical function that you maximize, I think that I cannot say that you didn't understand. It's just impossible for me. And I need to respect what you did. And if you did something, that I will show it in a minute. You are maximizing a mathematical function. And this mathematical function makes sense to the decision at hand. I will need to respect what you did. We have other measures to show understanding, but I really want to think that what I'm doing here, I want to understand everything from choice. We are also asking people, and we have controls, but everything is coming from choice. I can know from your choices whether you understood it or not.
Aspect and still have some utility function,
Yes.
because they partially misunderstand
Absolutely.
something.
I will be able to observe it. So let me give you an example, okay? Suppose, for example, no matter which line I'm giving you, you are always choosing the intercept with the y-axis. So this is basically, you'll have a function that you maximize. Your utility function will be just u of xy equal to y. It's like, you like y. Here, you are maximizing a function that is just not appropriate for the decision at hand. However, decisions like this will have a lot of violation of first-order stochastic dominance. Okay? So if basically there is a utility function that you maximize and you satisfy first order stochastic dominance, you understand.
So just to rephrase this, there's a wrong choice here, right? I mean, if they choose to the left of x equals 25, they're not maximizing expected value. And risk neutrality is x equals 25 or so. I'm
That's
just
right.
estimating, right?
That's
so you
right.
could look at their choice on this
Absolutely.
and say if they're to the left of that, they're probably not maximizing expected
Absolutely.
value. Or
So you are
expect them to.
maximizing the wrong function in some sense. I can see this. Okay, so we have a lot of experience with this experimental technique. Now, as I said, thousands of subjects. You know, we don't need to put people into MRIs. It's cheap. We can do it anywhere. Now we are also doing it on cell phones. So one of the things that we are trying to do now, instead of doing it in a laboratory experiments, we will give it to people during, on their cell phones. They'll do it over the course of the week. And we will track many things that they are doing, GPS and other things. So, it's portable to do it in many, many domains. Okay? And let me just show you that, let me close this and show you something else very quickly. If you have any questions, that's the time. Let me say that, we were very surprised by how people basically understand this. And just to show you, we have exactly the same interface with 3 dimensions. So this is exactly the same problem, but instead of having 2 states of the world, there are 3. And people are also doing this. And if you can see, this is again, if you are risk neutral, you need to go here. You see? If you're infinitely risk averse, you need to go here. So basically, I can't even find it. And being infinitely risk averse here is very costly. Okay? So any questions about the design? Now, let me just say one more thing, one last thing. Typically, when we make decisions in such an environment, we'll give people to choose binary decisions. What do you prefer, A or B? So first, when you give people to choose between A and B, you cannot check whether they are rational a la Samuelson. The data set is not rich enough. But even more, it gives you much less information. Why? With a binary or a discrete decision, the only thing that I know that is A is preferred to B. Here, if you choose a point from this set, it's a continuous set. I know that the point that you chose, it is revealed preferred. It is revealed preferred. From your choices, I know that it's better than any other point in the set. So it gives me much more information about your preferences, which is crucial. Okay? Moreover, because the data comes in a way like this, we can apply statistical methods that are not difference in means across subjects. All the analysis will be done here on the individual level. I will never put 2 people together. And the reason why I will not put 2 people together is because that if you pull 2 people together, even though I'm rational and Ron is rational, our data set is not going to be rational because there are going to be contradictions between our preferences. So we can explore the heterogeneity in human behavior by focusing at people at the individual level. Okay? So just to conclude this, let me say, if we have time, if we have time, I'll show it later. We can basically, we have enough data, just to explain how much data we have. If you know these pictures that economists like to draw of indifference curves, so we will have enough data to draw these pictures without imposing any functional form. Straight from the data, completely non-parametric, I will show you the indifference curves. You'll just see them. Okay? Okay, so more generally, with this design, we can ask these 4 questions. It's not my questions. Hal Varian in an Econometrica paper in 1992, for example, stating them. But this is what is called the 4 fundamental questions about consumer behavior. So the first question is about consistency. Is behavior, in this case under uncertainty, but it can be behavior not under uncertainty, is consistent with the utility maximization model? Okay? So for me, if the answer here is no, then I will say decisions are of low quality. And to be honest, I will look for a job in one of your labs, because I think that we need to close the economics department. Okay, so this will be a serious blow for economics. The second question, if the first question is right, then I can ask the second question. If behavior is consistent with utility maximization, do I maximize a utility function with some special structural mathematical properties that are important? For example, we are always concerned with expected utility. Expected utility implies maximizing a function which is additively separable. We can test this. Okay? So we can get deeper into the functional form of the utility function. The third question will be even a bit philosophical. Can we recover the underlying preferences from choices? Because to say that you are maximizing a utility function, and even saying that you are maximizing a utility function that is additively separable, doesn't mean that I know your preferences. Okay? From a variety of reasons. And finally, the only way that we can basically answer these three questions is in the laboratory. Data from the real world doesn't come in a level that we can use it. So we need to extrapolate or consider the external validation. Given behavior in the laboratory, can we forecast behavior in other environments? Okay, and what I will do today, I will basically only answer question 1, because I think it's extremely important to behavior change. Who is basically a good decision maker and who is bad, and I will jump to question 4. And if we have time, I'll do other things. Okay, so I think that this is, can you hear me? Is it fine that I'll stand like this? Okay. So this is, I think, this is one of the most important theorems in economics, and it's due to Sidney Afriat in a paper from 1967. And basically, Afriat is saying that these three conditions are equivalent. The data satisfy the general axiom of revealed preferences, that I will explain intuitively what it means in a minute. There exists a utility function that rationalizes the data. And there exists what economists call a well-behaved utility function that rationalizes the data. Now, the equivalence of the first two conditions is the strength of Samuelson theory. The equivalence of conditions 2 and 3 is the weakness of choosing on linear budget sets. And a lot of the confusion, so basically what it means, what the equivalence between 2 and 3 means is that even if you have strange preferences, they are not nice as economists think they are, you cannot observe it over linear budget sets. So, for example, people now in finance are saying that ambiguity loving, which is definitely something that we think it's kinky, this is what's driving the equity premium puzzle. Okay, this is absolutely wrong. It's just absolutely ridiculous. Why? If you'll think about the stock market as budget lines, and the stock market is budget lines, it's price and quantity, even if you are ambiguity loving, what this theorem says, you cannot express it. There is no room for you to express it. You can behave as if you are ambiguity neutral. So a lot of the behavioral biases that behavioral economists find, maybe you can find them in the lab, but you can never express them in the marketplace. Okay, so this is a completely different issue. Maybe sometimes, and Ron, this is to your question, maybe my preferences are inappropriate, but it really doesn't matter. It cannot affect my choices if you believe that the world is price and quantities. Okay, it can affect my choices over other choices. But in any case, what we want to understand is GARP. Okay, and the way for us to understand GARP is with the following picture, and I will explain it. And I will have to move now. So, okay. So, you need to remember that we have 50 decisions. So whatever I'm showing you now is done with 50 choices. But suppose I'll take you as an example, Ron, of course. Suppose you took only 2 choices. So you observed, you saw this budget line, and you chose point Y, and you observed this budget line, and you chose point X. And I'm saying that you are a low-quality decision maker. That you should not do. Why? You chose on this budget line, you chose Y. So what I can understand from this, according to Samuelson, it is revealed to me from your choice that Y is weakly better for you than any other point on the line that you could choose. In particular, there are points on this line that you are getting more in both dimensions from x. So from this choice, you tell me basically, the only thing that I can understand, that y is basically weakly better than any other point on the line, and strictly better than any point in the interior. Especially here, y is better for you than x. However, when I look at this decision, I'm reaching exactly the opposite conclusion. So you are being incoherent. You are being inconsistent. Okay? So with these two decisions, how can I remove your inconsistency? Now, it's a thought experiment. I cannot do it. I can remove this inconsistency by taking the line on which y was chosen and move it just under x. Then I'm going to remove this inconsistency. Or vice versa, I can take the line on which x was chosen and move it back such that it's going just under y. Again, I'm removing the inconsistency. So the measure that we are going to use, there are many measures of how consistent you are, how close you are to consistency. It's a wonderful question in applied math. There is no single answer. There are many answers. There is no ideal answers, but all answers gives us basically the same conclusion, so we'll start with one of them. So the one of them is here, think about it here, by how much I need to relax budget lines, or these lines, in order to remove the violation. And here, in some sense, the minimal way to do it is moving the budget line on which y was chosen, because we are moving it less than the budget line on which x was chosen. So here, this measure that Afriyat called the critical cost efficiency index is basically going to be A over B. And this measure, basically, it's a measure of how much money you leave on the table, not because of your preferences, just because you are not purposeful, you're just making these inconsistent choices. So how do we interpret it? If you don't have violations like this, your measure will be 1. If you have violation, your measure will drop below 1. For example, here it's A over B. And the difference between this measure and 1 is basically a proxy for how much money you left on the table. Okay? Now, you have to remember that we are doing it for 50 choices. So the way that the algorithm works is as follows. We are putting the 50 choices as nodes in the graph, and we are taking this, what is called directly revealed preferred relations, as edges. So you are getting a directed graph, a very large directed graph with 50 nodes. Anywhere you have a cycle in the graph, you have a violation. So only someone with no cycles at all will get a measure of 1. And let me tell you that the test is strong enough such that it will be able to recognize the effects of a trembling hand. If you just wrong with the mouse a little bit, your measure will drop below 1. Okay? Okay. Questions? Okay, so any questions? Yes. Very steep or very flat, you are choosing the relevant endpoint, this will be fine. But if you are saying in odd decisions, I'm choosing this, and in even decision, I'm choosing that, this will cause violations. Remember, the only relevant parameter in the environment here is basically the slope of this line. And if you condition your decisions on anything else, it will cause a mistake, because it's irrelevant for the decision problem at hand. Yes? So I didn't, excuse me? I'm going to answer something different, so I really don't. Now it will, now you exposed me. I'm going to answer something very different, I guess. So, because it will just take me too long. It's not that only the 45 is the right answer. There is no right and wrong answer here, which is also very important. It's not like an IQ test. There is no right and wrong answer. It depends on your preferences. Okay, so it is true, if you always go to the 45-degree line, it might be very good for you because you cannot tolerate any risk. I don't care about risk. So for me, it's going to be a mistake. However, which point you move along any line, if you condition what you do on anything else than the slope, which is the only, what is the slope? The slope is the relative prices between these two securities. It will be a mistake. And I will be able to see it. If we move quickly, I'll show you individual decisions, and you'll see, I think the greatest compliment that we got from it, somebody told us, this is like having an economic fingerprint. You will see no two people are alike, and we have so many decisions that you can really see. And then the same person told us, I'm taking it back, it's an economic blood sample. You're really getting what is people are doing. Yes. Yes, so we are moving, look, the people that did it in the Netherlands did it at home on their computer. Some of them even did it on their TV because they don't have a computer, and we are starting to go back to them even on different decisions. So you took a decisions under risk, then a few months after we tell you to take a decisions about time preferences, and there is correlations between the consistency scores. Now, in some sense, I don't think it's an interesting question. Why? Because I will care about it in external validity. I will show you that these consistency scores are basically very good in predicting huge economic outcomes. So I think that, let me say this. We'll get back to it. Okay, we'll get back to it. I disagree. We'll get back to it. We'll get back to it at the end, I promise. I'll get back to it. No feedback. I don't know. Let me tell you this. They are so rational without feedback. So you think that feedback will take them down? And which kind of feedback do you want exactly? It's not about winning here. No? So it is true that if, for example, I will show you whether you made money or didn't make money, it can affect your choices later, but it doesn't mean that it's irrational. If I feel that, I was too risk-averse and I didn't make enough money, I can gamble in few decisions. So feedback basically changes the experiment because accounts X and Y in decision round 5 are not accounts X and Y in decision round 10. And this is not what we are doing. So if people are going to change anything over time, if you give them feedback, it's not a sense of more rational or less rational. It's like moving in games from a one-shot game to a repeated game. It's a completely new world. So, really? Okay, so let me move on. Let me tell you, let me get to you immediately with what we are doing. So we are going to focus with this. So as I said, the panel that we are doing is a representative sample of the Dutch population. Of course, the sample is representative. When we recruit it, then there is sample selection into the experiment. We take care of it, no innovation here. We are just taking whatever other people are doing. I won't talk about it. Now, we are doing 3 types of analysis. The first one, I will just give you a very quick descriptive overview of the average quality of decision, which is this CCI, consistency with utility maximization. Then I will talk about the relationship between decision-making quality and sociodemographics. And finally, we are going to, I think that non-economists, it's hard for them to appreciate what we are doing, but we are jumping on a grenade. And basically, we are trying to catch the biggest fish. So usually what we are doing with external validity, we have a measure from the lab, and we are trying to correlate it with a single decision in the same domain in the real world. This is not what we are doing here. We are taking a measure from the lab, and we are trying to correlate it with the biggest economic outcome that we know how to measure, which is wealth. Now, wealth is basically made by gazillion of decisions over enormous amount of time that doesn't only involve risk preferences, it involves time preferences and social preferences and anything. And it's a puzzle in economics. There is a big question in economics, who accumulates more wealth? Why? Because if you take people that have the same income, the same household composition, the same education, you control for all of these observables, they develop very different levels of wealth in their life. Now, I'm not claiming, if we talk about behavior change, I'm not claiming that having wealth is good. So I'm not saying that wealth is well-being. But this is, I cannot measure well-being. So I'm measuring wealth, okay? Okay. So this is the first picture that I want to show you. It's a bit hard to see, so I'm sorry for this. So what you see here, this is the mean CCI score and 95 confidence intervals along some sociodemographics. Overall, people in the Netherlands is 0.88. So whether it's the Dutch are good decision makers or bad decision makers, I don't know. In this experiment, they left 12% of their possible earnings on the table. If you extrapolate it for GDP, this will be very bad news. However, on the other hand, if you make very little mistakes by moving the mouse here, you can drop to 0.88. Okay, females are a bit less rational than men, but here there is a very interesting question. It's not in the 20s, it's not in the 30s, it's not in the 40s. It's only in the between the 50s and 60s. This is what's causing it, and I will get to it in a minute again. Here, what you see is age brackets. This is not linear. I promised you that I'll talk about linear. This is not linear. There is an inflection point here, and it's just going off the cliff. Now, why is it? So we don't have enough data. Even though we have thousands of people, we don't have enough data to say, but now we got another grant from the NIA, and what we believe is that what is going on here, your consistency score drops when you retire. Now, of course, there is causality here. Maybe because it drops, you retire. We believe it's the other way around. When you retire, you stop solving trade-offs. You don't need to think anymore, when should I get up, how should I arrange my day, and doing all of this. So you stop solving trade-offs. And this is, by the way, why we think, and now we are testing it, females are less consistent than male. They are just retiring earlier. So I think that here, actually, the behavior leads to this drop. Okay? Other things that we see are pretty standard. Of course, this will be correlated with education, and it will be correlated with income and all the other things that you want. Now, Ron, to your question, this is about, let me just say, if you took Berkeley undergraduates, they will be at 0.96. And if you take Yale Law School student, they will be at 1. Just 1. Just no one has any deviations. And these are not people that study economics or have any mathematical reasoning. They're just smart. Okay? Now, this is for decisions under risk. What you see here is decision over time. And you see there is only an increase. So here we ask them to divide money between income in a few days and incomes in 60 days after. And as you can see, apparently making these trade-offs over time are easier than making trade-offs over uncertainty. Everywhere you see there is an increase, but the patterns stand the same. And even if we take these decisions into the future, dividing money 60 days from now and 60 days after that, exactly you see the same patterns. Okay? Okay, so this is about, yes. Yes, no, we still get a very strong inflection point for age. Very strong. Let me say that when you run when you put age on the x-axis and you run and you try to fit flexible polynomials to this, none of them will be linear. The relationship with age or education or it's all or income, it's all non-linear. There is no linear relationships here. And you know, if I impose linear relationship on age, it means that your economic rationality between age 20 and 30 drops in exactly the same rate like between 60 to 70. There is no reason to believe that this is the case. You know, even here, we are not losing it in a linear way, right? One day comes and we are losing it. Okay. You know, whatever I did here, I just talked about consistency. I can add another measure. I don't have time to explain it about dominance. But if you, this is meaning going to the other side of the 45-degree line. But if you ask me how rational the Dutch are, let me just give you a scatter plot. So what you see here, this is this measure of CCEI, and this is exactly the same measure going between 0 to 1 of mistakes of going to the other side of the 45-degree line. This is in some sense whether I'm maximizing a utility function that makes sense. Economic theory says that we should all be in the top left corner there. Let me tell you that the 4 squares that you see there, it really can be interpreted as the effect of a trembling hand, and 80% of people are there. And what can I say? You know, some people cannot cross the road alone. They really seriously need help. They cannot solve trade-offs. But, you know, 80% of these people in the Dutch population, I cannot say that they are irrational. At most that I can say that they are making mistakes, mistake in implementation. But there are, of course, people that are problematic. Okay, so let me just, before I go to something else, let me just talk about this. You know, people now in development economics are explaining what is called the development gap in 3 ways. One way is the standard way. Some countries are rich. They have oil. They have other things. The second way is that some countries are, have institutions. It's a question where this institution came from. But some countries have institutions, some countries not. But there is another view in development that some countries are poor because people are low-quality decision makers. So what we did exactly these experiments with Berkeley undergraduates, which I like to think about of them as the best in the United States, and students in the University of Dar es Salaam in Tanzania. And in Dar es Salaam in Tanzania is what you see low and high. Low stakes was hourly wage, high stakes was 6 months' wage of a professor. So we are talking about a lot of money. And let me just say, what you see here is these measures of rationality. I just want to mention that we also did Raven's matrices. We also did IQ tests. And when you run IQ tests with these people, the bottom 10 percentile at Berkeley is the top 10 percentile in Tanzania. These 2 distributions just don't overlap at all. And if you look at IQ, you would say that there is a huge gap in cognitive ability between the students in Tanzania and at Berkeley. When you look at this, the Berkeley undergraduates are still more economically rational, but not by far. And if you look at the mean at Tanzania, it's 0.855, very close to the mean in the Netherlands. And when you increase payoffs, they are only getting better. Okay, they are only getting better. And we have also measures of risk aversions and others. So it gives very different conclusions than IQ scores. Okay, so let me do the last thing. And how much time do I have? 3 minutes. Okay, so what are we going to do? So I'm sorry for the size. There is just no other way to fit this. You know, I'm not an empiricist. I'm not dealing with data. Basically, I'm a theorist. And my belief about life that if you run enough regressions, you'll finally run the one that will break your heart. But so far, although I tried hard, I know that it's hard to try to break your heart, but you want to break your own heart, and not somebody in a seminar will break your heart. We weren't able to break the result. So what we are doing here, on the left-hand side, we are having household wealth, including everything, real estate, everything. And on the right-hand side, we are controlling for, as you can see, we have income, we have family structure, age, education, occupation. The parameter on this measure, called the CCEI, is 1.351. It's in logs. So basically, you can interpret it, the correlation as follows. 1 standard deviation from the mean CCEI in the experiment is associated with 15% more household wealth. These are just numbers that are out of the world. You can't get numbers like this. And I'll just go over it quickly. The result stays the same no matter what we'll do. And in the regressions, we are going to try to do it, and we are basically going to try to kill it. So how can we try to kill it? We can say, look, for example, here we are saying we didn't condition enough on income, or income enters into the regression in a linear way. Let's do it non-linear. So we are trying to do it in many ways. And the other ways that we are trying to kill it is by taking, for example, the Big Five and the cognitive reflection test and IQ. And let me tell you that nothing kills it. For example, you can see here in column 3, we are adding many measures of risk tolerance, both from the survey and from the experiment. And we are adding measures of conscientiousness, which is, this is among the big 5, this is the one that basically predicts economic outcomes. But look at the top, nothing happens to the CCAI, which basically means that we are capturing something distinct. It's not conscientiousness, it's not education, it's not income. Of course, it is correlated with all of these things, but it's not that. This is economic rationality. It's something different. So maybe I should say what I think that the bottom line here. The bottom line here is to basically going over people across domains and finding Shachar and saying, oh my goodness, Shachar needs help. He just cannot solve trade-offs. And maybe here we can change his behavior. Now, how to change it? It's a good question. Maybe Shachar is so bad that even if you give him information, there is nothing he can do with this. So at a certain point of time, maybe you need to make decisions for him. Okay?
Okay, so I've been enjoying this conference a lot so far. The topic of behavior change is something that's really critical for us as a field and for really what our ventures should be about. And my area of research is focused mostly on emotional memory. And so in coming to this conference, I was thinking about how are the ways that emotional memory support behavior change. And so what I'll be telling you about today are 2 lines of research that I think have some provocative data about how emotion and stress will affect behavior change. And the first thing I wanted to do was actually to take a poll as to your intuitions about what I'll be telling you about. And so the first thing that I'll be asking in this talk and trying to address is the question of how stress influences learning. In particular, the type of learning I'll be looking at here is learning from positive versus negative outcomes. So you might do a particular strategy, you might pick a particular thing, you might make a particular choice, and you get an outcome. And in life, quite often, these outcomes vary. So sometimes they're good and sometimes they're bad. But over time, there might be an option that generally leads you to a better choice. You know, a particular route you're driving to work in the morning generally is faster than another route. In LA, these sort of decisions are quite important. So the question about stress is, if you are under acute stress, so that morning you just got some really bad news, you're very stressed out, or you're going to be giving a big presentation, something like that, how is it going to influence how well you learn from positive versus negative feedback? And so I'll give you 3 options here. The first would just be that it influences learning in general. The second would be that it enhances learning from positive outcomes, but impairs learning from negative outcomes. And the third is that it enhances learning from negative outcomes, but impairs learning from positive outcomes. So first, poll of hands for option A, that it enhances learning in general.
Before you ask,
Yeah.
are you talking about explicit learning or implicit learning, or both?
Here, what I'm going to be showing you are things that are you're learning gradually over time and then you're asked explicitly, or just you're making choices and it's revealed from your choices what you've learned.
So it could be.
Yeah, so, right.
Okay, so go ahead.
Another.
Is learning correct learning? Meaning I learn, I can learn and make even worse decisions, but I still learn. But
Right.
I refer to learning actually good learning.
Yeah, so if something is probabilistically more likely to yield positive outcomes, do you choose it more often? If it probabilistically leads to bad outcomes, do you avoid it more often?
So I would guess, just a wild guess, that every positive event causes you to learn, but you really need very negative events in order to learn.
So, and then the question is, how does stress change this general tendency that we have? So, how many people would say that stress is going to enhance both types of learning? Okay, we have a couple takers on that. And then that it enhances learning from positive outcomes, but impairs learning from negative outcomes compared to your general tendency. We have one taker for that. Okay, and then C, it enhances learning from negative outcomes, but impairs learning from positive outcomes. This is the majority of the room. Okay, so that's interesting. It was really interesting getting your intuitions on this, because actually we're hypothesizing the minority, what the only one person took here, which is that stress is going to enhance reward salience and enhance the degree to which you learn from positive outcomes. And we have some data supporting this as well that I'll be telling you about today. And I'll tell you why we think this is the case as well. But first to part two, which is a separate question, which is how does the emotion associated with information in an event influence the flexibility of memory? So behavior change, in behavior change, it's very important that we update our memories. So you might have learned that a particular commute option, coming back to that one, is good, but then there's construction. You need to learn to update and be flexible and change your behavior. And if you're not remembering this every morning, you'll just end up surprised and late to work again. So if there's some sort of emotional component to this information, is it going to be more flexibly or less flexibly updated in memory? So in psychology, we quite often have these paradigms where we do reversal learning. So there's an A choice and a B choice, and it's used with animals as well, and the A might yield reward and the B would not yield reward. Does the fact that the outcome is emotional allow you to more flexibly update the change later, or does it make it more difficult? Or if you have some object that is in itself emotional, like a gun, and you've learned where it is in your house, you've seen it, or in your friend's house, and you're very aware of where it is, but the next time you come over, that gun is in a different place, is that going to be harder for you to update that location than if it was some neutral object like a notebook? So that's the question. And the two options for you is that emotion, the inherent emotion is part of that memory representation, will lead you to be better at updating and have more flexible updating of the memory representation, or will it impair it? So how many people would go with on their intuitions, go with the enhances updating? So we've got a good half, maybe a little more of the room. How about impairs? Looks like about a third of the room. Okay, so we're pretty close to even here. The hypothesis that I'll be telling you about today is that what's really important for updating things that are inherently emotional are interactions between the amygdala and orbital frontal regions. And the really interesting thing is that the amygdala, while it enhances your initial memory for things that are emotional, it also seems to be working very hard to keep those things stable. And so it makes it very hard to update things that are emotionally arousing. And I'll be telling you about behavioral data and some neuroimaging data along those lines. So these are two separate lines of research that I think have some interesting things to say about the way that behavior change will be affected under stress and emotion. And I'll be talking a little bit about how these relate to aging as well. Yep.
Just quick. Mm-hmm. And you're agnostic as to whether it's positive emotion or negative emotion in this second?
In this one, it's about emotional arousal, so both positive and negative would, in our framework, would act the same way. Yeah.
They're both the same.
Yeah. So the first hypothesis that I'll be talking about is this idea that stress will enhance reward salience. And there's a number of reasons to think that stress, acute stress in particular, so, the stress you have before giving a talk, the stress you have for a few hours when you've gotten really bad news, that sort of thing, that it will change how we respond to rewards. And we've outlined this in a recent review paper, and we're calling it the STARS model, for that stress triggers additional reward salience. And the background literature that led us down this road is that in rats, stress increases dopamine levels in the nucleus accumbens and also in medial prefrontal regions that are very important for processing reward, as we heard about already from Brian. And here are just some old data along those lines, but this is from a number of studies with rats. This increase has been seen. And then also in humans, PET research indicates that pain stress increases measures of striatal dopamine in healthy young adults. And then there's a large literature on addiction that shows that stress can increase the likelihood of acquiring and maintaining drug addiction. So it seems like under stress, rewards, that cigarette, even though you've quit smoking, the reward of smoking that cigarette has a stronger pull under stress. So these are reasons to think that reward is particularly powerful under stressful conditions. So we looked at this in a laboratory context. And what we had people do in order to induce stress is a commonly used physical stressor, which is that we asked them to hold their hand in ice water for 3 minutes. It doesn't sound so bad, which is nice for us recruiting participants, but it's actually pretty painful. If you get past the first minute, it's fine. Your hand gets numb. But then what we do is we have people play various games at the time of peak cortisol increase, which is about 20 to 30 minutes after the stressor. And we measure cortisol levels and they increase. And the task we used here was a probabilistic learning task. And this task is one that Michael Frank has used in many studies, and he's found relates to dopaminergic processes. So the way the task works is that they get these characters that they're probably not familiar with, and they're just asked, okay, pick one of the characters and you'll get feedback about whether you're right or wrong. And so if they pick this character, 80% of the time they get feedback that says correct. And if they pick this one, 20% of the time they get feedback that says correct, and the other rest of the time they get feedback that says incorrect. So over time, people gradually learn to pick this A character and avoid the B one. There's also 2 other pairs where it's a little bit harder to learn because the contingency is 70-30, and then here 60-40. And they go through this session until they're above chance on all of these. And then at the end, they are asked to make an explicit choice between repaired options. So here A is repaired with all the other options. And what should you do in this case? You should always pick A if you've learned it, because it is the one that has the highest probability of all the options. And then B is repaired with everything. And what should you do in this case? You should always avoid B because it's the lowest probability. And what Michael Frank has shown is, for instance, with Parkinson's patients, when they're on meds, they are better able to choose A than when they're off meds. And he's also shown that dopaminergic, just giving normal people agonists or antagonists influences this as well. What we find is that under stress, people learn better about the positive outcomes. So in younger adults, under stress, they are more accurate at this choose A decision than they are in the control condition, and they're slightly, although not significantly, less accurate at avoiding B. And this interaction is significant independently, both for the younger adults and the older adults. So it looks like a very similar effect in both younger and older adults. So this was very interesting, and we wanted to see if we could extend and replicate it using a somewhat different paradigm with more intense social outcomes. So here again, it's a laboratory task. They did it again about 20, 30 minutes after being stressed with cold pressor. And the task was always to pick one of these 2, we called them slot machines. And the slot machines differed in their contingencies of yielding feedback. And the feedback was an emotional face that said things like wonderful, terrific, and they heard the auditory sound too, the word, or it said moron, idiot. And so it was a little more dramatic than just seeing the word correct or incorrect. And then there were also neutral outcomes where the face was neutral and they would say things like chair. So you've got some positive feedback, negative feedback, and the way the contingencies worked is that there were some pairs that were on average positive. So this pair, for instance, this slot machine might be a positive one in that it yields positive feedback most of the time and sometimes neutral feedback. This one is mean neutral in that it yields, on average, all types of feedback. But the pair itself is on average positive, whereas then we had some negative pairs where they should be learning to avoid the negative slot machine and go with the neutral one. So we can measure these two types of learning for these different pairs. The first thing I'll show you, it harkens back to things actually both Brian and Kevin mentioned about older adults, which is that in general they tend to remember positive things better than negative information. And we found overall just this effect here where older adults were better able to select the positive slot machine than they were to avoid the negative one.
They were asked to choose the positive one, or
They could choose whatever they wanted.
so maybe younger adults just like the negative more and stuff.
They liked being called moron, right?
I would choose that.
Right, right. So this was the overall effect, and then what we were particularly interested in is whether how stress was modulating these things. And at the end of the experiment, what I'm showing you here is we asked them how motivated they were. So this gets to your question: how motivated were they to seek out positive or negative feedback? And what's very interesting, just on this one question, their self-report of how motivated they were to seek out different types of either to get that positive feedback or to avoid the negative feedback, we have a significant stress interaction. So under stress, the younger adults report being more motivated to obtain the positive feedback and less motivated to avoid negative, whereas they're a little bit more motivated to avoid negative in the control condition. And so this overall interaction is significant, and it's significant for the younger adults. It on its own, it's not quite significant for the older adults, although they're showing the same pattern. Then we have just what are their choices during the task? And what we see is, again, for younger adults, they're showing this stress-enhanced learning about positive outcomes. They're making more of these choices that lead to the positive feedback under stress than they are in the control condition. Interestingly, this effect no longer holds up in this for older adults, because in the control condition, they're showing a pretty dramatic positivity effect. And it's not, stress is not enhancing that at all. If anything, it's attenuating it a little bit. So what we have here are two studies that show that stress-enhanced learning about positive outcomes and also the motivation to seek positive outcomes. And these effects were seen both in younger and older adults, but not so much in the older adults when they're at baseline already really tuned into the positive more than the negative. So that's the first part, and I think this has a lot of really interesting implications for behavior change. If you are trying to change your behavior and you're in a stressful situation, it's really interesting that what you'll respond to, be more motivated to seek out and learn better from, are positive outcomes than negative outcomes. And it suggests that we might want to think about ways to structure interventions if it is in a context where people might be experiencing stress and they want to change behavior. Now, for the second part, in terms of behavior change, memories need to be flexible and be something that you can change when reality changes or the contingencies change. How well can you adapt your memory representation? And in terms of emotion, most previous research has focused on how the emotional nature of what's out there affects your initial memory. And there's lots and lots of research on this. And, sort of the main finding would be that if something's emotionally arousing, like a gun, you tend to remember it and its location better than something that's neutral, like a notebook. But what happens if you're trying to update those representations? If you go over to your friend's house and now the gun is in a different location, will you be less, less adept at remembering where it is than in that new location than if it was something neutral like a notebook. So in terms of memory updating, there's a lot of paradigms in the literature, in the memory literature, that are relevant to this. And interestingly, people have not looked at the role of emotion. So one common way that people have looked at this is looking at proactive or retroactive interference. So you might learn that A and B are a pair together. They go together. And then on a second test, you're asked to learn, oh, now A and C go together. And people have a harder time learning that A and C go together if they previously learned A and B go together. But people haven't looked at how whether the emotional nature of these stimuli will affect that ability to update information. Then, as I mentioned, there's paradigms where they look at reversal learning. So if you have choices A and B, and you have learned that A yields a positive outcome, but the contingencies change. You're not explicitly told about this, but now when you choose A, there's no longer a positive outcome. How well can you learn that? Interestingly, those paradigms typically involve emotional outcomes. You know, these sort of paradigms originated with the animal literature, and you pretty much, you know, almost really want to use emotional outcomes like food, things that are rewarding, or punishment like shock, to get them to make choices. But there haven't been comparisons. What if the outcomes are not emotional? Is reversal learning easier, or is it harder? And that's what I'll be telling you about today. And then there's also relevant things from the extinction literature. So you've learned this choice over time, it goes away. How long does it take you to extinguish your behavior that's no longer useful in this context? And what I think brings all these three things together are the neural mechanisms that we know about so far, and something that's really interesting that hasn't gotten a lot of attention. So we know from many studies that patients with lesions in orbital frontal polar region, so here's an analysis of multiple subjects with brain lesions, and this is the different subjects that have brain lesions that are in orbital frontal and the frontal polar regions of the brain, and these patients have difficulty not in learning an initial association, but in reversing it when it changes. And so that's a classic finding that's been seen in many other studies as well. And the interesting thing is that there's some studies showing that the amygdala actually might be working against this updating. So one of these studies that I found so unbelievable when I first read it was this one by Stalnaker et al., where they gave rats orbital frontal lesions and then they trained them on these tasks and then did reversal, and of course they're impaired. They had another group where they gave them the orbital frontal lesions and also amygdala lesions. They were not impaired. So they had 2 lesions, and now they're better off than when they had 1 lesion. So the amygdala is apparently working against updating, and the orbital frontal cortex seems like it is suppressing that amygdala function, allowing you to update. So if you take away the orbital frontal cortex, you have a deficit, but if you also take away the amygdala, you no longer have a deficit. And that is consistent with some monkey research as well. So orbital frontal lesions impair extinction, but in the same study, amygdala lesions enhanced extinction. And sorry, I think that's reversed. Right, so, right, no, that's right. And then amygdala lesions also enhanced reversal learning in monkeys. And in humans, neuroimaging studies showed that frontal polar Brodmann area 10 region showed greater activity during successful extinction learnings trials, and also showed negative correlations with the amygdala in a functional connectivity analysis. So first I'll just tell you there's several studies we've done that show behaviorally that it's more difficult to learn new associations to things that are inherently emotional than to things that are not emotional. So we've done this with tones and faces that are themselves neutral but have been conditioned to be emotional or neutral, and it's harder to learn new perceptual information about them. And when the location of a picture switches, it's harder to learn its new location if it's an emotional picture than if it's a neutral picture. Whereas we've seen also that you have better memory for the location of novel emotional pictures than novel neutral pictures. So I'll give you a flavor of this sort of effect here. In one study we did, in the first phase, people are asked to learn associations between pictures and objects. And some of the pictures are emotional and some are neutral. And then they're tested on these associations. And the picture always appears in the middle of the screen in this phase. And then in the second phase, the picture appears in one of the outside quadrants of the screen. And then they're asked to study its location, and they get tested on its location. And here we had not only old pictures from the previous round, but also new pictures that were either emotional or neutral. So we could see how does emotion affect your ability to learn the location of a picture, and how is that influenced by whether you've seen it before or not. So the first thing I'll show you here is both younger and older adults show better location memory for emotional pictures seen for the first time. So it's like that gun. You see it, you'll remember where it is, better than something neutral like a notebook. But then if you'd seen that before, it was an old picture in that location learning phase, you're actually worse at remembering where it was than if it's something neutral that you saw before. So it's harder to update and learn new information about these emotional things that you'd previously been exposed to. And so as I told you, our hypothesis is that this is related to interactions between the amygdala and orbital frontal polar orbital frontal cortex, that and the amygdala is what is trying to maintain that initial powerful emotional memory, and orbital frontal cortex is countering it, making it more possible to learn new associations. So in an fMRI study, we had participants do something very similar to what I showed you in the behavioral study. They had a phase 1 where they initially learned pictures, and then they had an updating phase where they learned locations of pictures. And in phase 1, we had two types of ways that they learned about the pictures. They either had to learn its association with an object, or they were asked, have you seen this scene, or has your mother seen a scene? And then they had to say, what was the question beforehand? So two types of things. We got the same effects for both of these initial learning type tasks. Then in phase 2, we had participants study the picture location, and then they got a test for it. And the question is, what does brain activity look like during this updating phase when they're learning new information, both about new pictures and old pictures that either are emotional or neutral? And what we see is that in the amygdala, we, just as you would expect in an amygdala ROI, we see greater activity during negative pictures than neutral pictures. And also we see that there's greater amygdala activity for the neutral pictures that are novel than the ones that are old. So we're getting both a novelty effect and then also an emotional effect here. Then for the negative pictures, what we see is that during this updating phase, old pictures showed greater frontal polar orbital frontal cortex activity than did the new pictures. So we're seeing this frontal activity that's associated with having seen something emotional before that you need to learn something new about. Whereas for the neutral pictures, it makes no difference whether they're old or new pictures. There's no greater frontal activity for the older pictures. And when we did an interaction, we see a particular region in Brodmann area 10 that is greater for the negative pictures that were seen before than the negative pictures that were neutral compared with these neutral pictures. So this region then we used as an ROI to look at functional connectivity across the brain. And this is just showing you in the negative picture conditions what functional connectivity looked like. And so this Brodmann area 10 region is positively correlated with the other frontal regions, but negatively correlated with the amygdala hippocampal regions during viewing of negative pictures. So we're seeing this negative relationship between frontal and amygdala regions. And when we looked at how that compares to neutral pictures, there's greater negative correlation between this frontal cluster and the amygdala and hippocampus during location learning for negative pictures than there is during neutral pictures. And also the left and right amygdala here. So how does this relate to what they end up learning? The old negative pictures that they actually remembered the locations for had a stronger negative correlation during that learning part between the frontal broadman area 10 and right amygdala than those with locations that were not learned. So this negative functional connectivity seems to help them in updating their memory. The orbital frontal cortex activity seems to be, frontal polar activity seems to be actually helping them by working against the amygdala maintaining that initial memory. So these results support the hypothesis that the frontal cortex counteracts amygdala influence, which allows people to more flexibly update their emotional memories. And that this is particularly important for emotional memories, not so much for neutral memories. So if this is the case, we should see similar effects during reversal learning. And as I mentioned, in reversal learning, you might get a choice between two things. You've learned one thing yields a positive outcome, and then the contingency switches without you being explicitly told. So here's how we implemented the task in order to have both emotional outcomes and neutral outcomes. So we asked people to make a choice, tell us which person will be happy. And at first they have no idea, right? They're guessing, so they might guess this guy. And it turns out he's happy. Now the screen turns gray to show that this is the outcome. And then another trial, okay, well, who will be happy? Well, he was happy before, I'll try him again. Sure, he's happy again. Okay, third trial, who will be happy? I'll pick him again. Oh, he's not happy. So this is the outcome screen. As you can see, when they're wrong and the contingencies change, both faces are neutral. So this allows us to have the same perceptual outcome across all of our types of trials, as you'll see. So this is where reversal learning should be occurring in our scan sequence. And then, they might continue. Now they're selecting the other guy and sure enough, that's right. So here's what the full design looks like. Here's the happy version that you just saw. Here's an angry version. They're asked to pick the person who will be angry. And then here's a neutral version. They're asked to pick who will wear glasses. And what you see is that the outcome for all of these is the same perceptually. And that's the part of the scan that we will be analyzing, is that outcome where there's a reversal, but it looks the same in all trials. And during those reversals, if they were neutral reversals, it was the eyeglasses condition, they showed less prefrontal activity than if it was an emotional, either positive or negative reversal. And these activation coordinates here were seen most strongly for negative reversals, but they were also seen for positive reversals as well if we lowered the threshold as well. It's very similar activity, just not as strong. But overall, we're seeing these ventral prefrontal regions that are showing stronger activity when the reversal is about something emotional than when it's about something neutral. And we ran this study with both younger and older adults, and we see very similar activity in these two groups. So the left lateral OFC region that was shown on the previous slide, if we just look at what the activity is like for younger adults across the conditions and older adults, they're both showing the strongest for angry and least strong for neutral. And then the amygdala also is showing strongest for angry and least strong for neutral. And this left lateral orbitofrontal region showed more negative functional connectivity with amygdala and parahippocampal gyrus during negative reversals than neutral ones. So again, we're seeing this negative relationship between orbital frontal cortex and amygdala that's associated with these updating of things that are inherently emotional. So to summarize this part of the talk, I've been making the case that it's harder for people to learn new associations to old emotional information than to old neutral information. So this, you can think about this in your everyday life. If you've learned something that is inherently emotional, like my example about the gun in a friend's house, you know, the next time when you're trying to learn something new about it, that will actually probably be harder for you to update that representation than if it's something neutral. And in addition to enhancing initial memories for emotional events, what seems to be going on is that the amygdala is holding on to those initial memories, protecting them in some way, but making it harder for you to update them and learn new associations. And that the orbital frontal regions seem to be very important in countering this influence to allow you to update things that are emotional. And so this is very interesting, you know, just from the neuroscience perspective. We've known for a long time orbital frontal cortex is very important for reversal learning. What these data would suggest is that really what they're important for is reversal learning of emotional things. And that if you scanned people with paradigms that were reversal learning but not emotional, you would see the orbital frontal cortex a lot less in those paradigms. And interestingly, we've shown across a couple paradigms that the mechanisms are shared for memory updating and reversal learning, and it's probably also similar things in some other paradigms as well. So to conclude broadly across the things I've been talking about today, I would argue that flexible learning is really critical for behavior change. If your representation of the world doesn't change, you're not going to change your behavior. If I still think that route to work is the best one, even though I keep encountering construction traffic, I'm not going to change what route I take. And so it's really important for us to be able to update our representations of the world in order to change our behavior. And the first part of my talk indicated that stress is going to influence how well we learn about different types of outcomes. And acute stress enhances learning about positive outcomes compared to negative outcomes. Interestingly, and this will relate to the next talk, I think chronic stress could be quite different. Chronic stress in the animal literature actually shows opposite effects in terms of its dopamine influences in ventral striatum. And so we haven't tested chronic stress, but it could be that it's actually opposite. So perhaps those of you who had the opposite intuition at the beginning, you might have been thinking more about chronic stress. It could turn out that you're correct if we were looking in that domain. And then in the second part of the talk, I talked about how emotionally intense stimuli lead to enhanced initial memory representations, but those representations are less flexible than they are for neutral memories. And throughout the talk, I had data from both younger and older adults. I didn't emphasize it too much because actually it turns out it's very similar. So these effects, for the most part, older adults are showing very similar patterns, sometimes a little bit attenuated. So in terms of behavior change, they'll most likely have similar interference effects from emotion in terms of trying to update memories. Stress may have similar effects as well. So I'm very interested in your questions, and thanks for your time. Yeah, Ron.
So it's very, very interesting set of findings. I have two related questions about the relevance of this to clinical populations. Mm-hmm. Certainly one area of behavior change is getting people with anxiety to have graded exposures and learn not to be afraid of a set of objects. And so it seemed like that would have implications. And the second that I just was thinking about is the finding among sociopaths that seem to have impaired reversal learning. So if you think of emotional arousal, that low emotional arousal individuals as they're characterized, and one of the learning deficits they've shown is this impairment in reversal. So I'm wondering maybe I'm interested in your thoughts about how these findings among normals may have relevance to some of these clinically relevant dimensions of impaired behavior change and learning.
Yeah, no, those are great questions. I haven't thought a whole lot about the clinical implications, but I think there are a lot of them. The anxiety thing is very interesting. I mean, these findings would perhaps be one explanation for why it's so hard for people who are anxious about, someone who's phobic about a spider, for instance. That's very emotional. They might have had an initial, encounter that is powerfully remembered, and that the more intense the inherent emotion about that, the harder it could be to represent it and change that memory, how they're thinking about spiders. So that would relate very much to that. Sociopath is really interesting. I would have to find out more because I don't know that much about them. Do they have, intact amygdala, but impaired orbital frontal?
It's
Yeah.
in my area. I know, James Blair's lab has been one of the leading, there are a few labs that have been looking at this actively, and maybe there are other people in the room that are closer to this, and there have been competing models about fast attentional differences versus, deep processing differences that people are arguing about. But the idea that the reversal learning could be related to the lower affective arousal dimension is something that I haven't heard anyone talk about in terms of the relationship between the sets of findings that have emerged. So, other people.
Yeah, no, that would be very interesting. I'll have to take a look and see if I can figure out a little more about the sociopath. Yeah, so Brian had a stand up.
Yeah, so really interesting data. I wouldn't predict it. I was trying to think about your interpretation of I'm talking about the first part of your talk. The stress increases the salience of reward. And going back to your rat data, the rat data you showed with microdialysis, I believe. So dopamine is released under stress. So there's something interesting about that data. I think they're restraining the rats in a tube. They can't move. They don't like it, just like babies. Dopamine is released. But as the rats learn that procedure, so they're in the tube for an hour, the dopamine release then moves to when the rats are released from the tube.
Right.
Okay? So, if this is the data I'm thinking of, right? So that would suggest actually that maybe it's not so much the stress per se, but it's the relief from the stress that is causing this shift, because affect is dynamic and so forth, and we're always obsessing about when is affect occurring. And so if that were the case, I was thinking about your data, then I would make 3 predictions. The first prediction would be that they actually feel better in your stress condition before they undertake your task. So if you had a PANIS or something on them, that was PANIS state, you could probably pick it up.
I think we do, yeah.
Do you have something like that?
I think we do, and I don't think there are differences, but I have to go back and check.
Okay, yeah. That would be counterintuitive, but it would be consistent with this relief. The second would be that if you made them do the task while their hand was in the water, then you would see a reversal. And this is related to your chronic stress implication, right? And then the third is that the cortisol release actually shouldn't be correlated with the effect you're observing.
The cortisol release is correlated. We don't yet have the court results for the second study, which is in preparation, but for the first study, cortisol change is related to positive
Okay, so then
learning.
the question is it the cortisol in response to the water, or the cortisol in response to, you're calculating change score, so before versus, or during versus after, right?
So before they start the whole session.
So is it
versus,
the decrease afterwards?
No, it's the increase.
No, it's got to be increased, yeah.
To the peak.
So, I
yeah,
guess
so
you can't
that would
get it.
argue
Yeah,
against what you're saying.
Yeah,
So we do
yeah.
get relationships with cortisol, which...
Okay, so that
Yeah.
would go against what I'm saying, I
Yeah,
guess.
but I agree with you. It's ambiguous. With our task, there's both there is that you're coming out of it.
Right.
For the cold presser, it's like I said, it's interesting. We have 3 minutes, and so the hand goes numb. And so there isn't that sort of, pain is over.
Right.
When it's that first minute is really painful, and then it sort of gradually goes numb and it goes away, and you're still in the water, but it doesn't. You could keep going.
It's not as bad, right?
Yeah. So it's not like the constraint sort of thing where you're still and then you're suddenly released.
Yeah.
So those things, and I'll have to look at the PANIS, but those things would argue against. But I do agree there is that in the rat data, there's that ambiguity because the dopamine then.
Well, also with the PET data on pain, the
Right.
dopamine release is actually in John Carr-Zubieda's data related to the intensity of the placebo relief from the pain. So the direction of the association is actually not correlated with the pain per se, but the relief from the pain in his data. But I don't know if that's the data you're talking about.
Right.
Anyway, thanks.
Sure.
On your first study, you said that number of trials was variable, and it just needed participants to perform above chance.
Yes. Yeah.
Did you find any differences there?
So there are
is acquisition also affected by condition, or is just performance?
So there's a main effect of stress, so that they are less effectively influenced by the previous trial. So, if what they're learning from the previous trial is less influential under stress, I don't think there's a stress effect in just how long it takes them to get through the procedure, though. And there are age differences, so it takes longer for older adults. But older adults showed similar. I don't know if we can fit in one more question. She's been. Oh, okay.
15 more minutes, which is more or less. Yeah, we have plenty of time.
Oh, okay.
Yeah.
Okay, so, or is that all right? Yeah.
This is a very applied question. We do work in traffic safety research, and the big thing is norm change. And just like we did with DUI and seatbelts, we're trying to see if we can do something about speed and aggressive driving and change the social norm. So how do your findings inform that effort?
So in terms of behavior change for speed and aggressive driving, we actually have some data that I didn't talk about today that were published a couple years ago, where we did the same cold pressor task and then had people play a driving game. It's very simple. It's not, it sounds sophisticated, driving game, but it was just a little car, and then they would get points the further they drove during a yellow light, but the light could turn red at any point. If they were still driving, they would lose all their points from that trial. So it was a risky decision task that had to be made under speed and sort of uncertainty. And under stress, older adults became more conservative in their driving, whereas the younger adults took more risk. So those findings, might have some applied relation, but then you're really looking at trying to change behavior and what, over the long term, what can you do? And so, you would want to figure out in what context are they really learning about the outcomes of what they're doing? And how can you make those outcomes impactful and something that, will influence change? Well, if they're under stress, yeah, perhaps. So, yeah.
So one thing I keep on thinking about in this whole line of work is whether this would be a place where,
considering the particular emotion, might be valuable. And two things came to mind. We were talking yesterday, some of us, about Jen Lerner's work on how different kinds of emotions can influence things like the endowment effect. So if you're in a sad mood and I give you a coffee cup, it's going to have a different effect in terms of how much value you're getting it has to you than if you're in an angry mood. And so there's that kind of a theme. I was also thinking about reversal learning and that in particular emotions. So if you've learned sometime in your life that cheese makes you nauseous, and so that's kind of a disgust response. Is real. In fact, you can have one trial learning that will last for life. But if you learn that people asking long-winded questions are aggravating, you can totally relearn that and say, oh, they're really interested in my talk through reappraisal, as we learned about yesterday. So there might be a lot of malleability, and so I was just wondering how you thought about it. One of the things that's a little peculiar about what you're doing is that your stressor is a pain stressor, and then your emotion stimulus, I'm not exactly sure, what emotion you're getting at. But I'm just wondering if some of these rules might be very emotion specific. Could have a lot of implication for aging, as you've shown, the emotional palette changes some over time. Long-winded.
Yeah. So what I would, I would think, given the model that we have, that what's going to be more important is the sort of arousal level in the second part of the talk, about how the intensity of the emotion is influencing updating. So, if it's something that really is strongly activating the amygdala, is really very intense arousal, then it would show more of these effects than things like maybe sadness that are low arousal, negative emotions. But that remains to be tested, and it would be interesting to see if that's the case and whether there are age differences. But the complicating part is that there might be age differences in which emotions induce more arousal. And so it could be mediated by arousal, but be things that different specific emotions yield different effects.
Yeah, so for example, you think of the early amygdala actions as being very fear-oriented, but maybe the most salient emotional stimuli later in life are the ones that are not around threat like that, but more around loss. And so that would be an interesting possibility. It still might, it's got to go through a common pathway. I mean, it's not just magic. So it has to be something like amygdala activation or maybe norepinephrine secretion or something like that that's going to be explaining it. Yeah.
Thanks for a really interesting talk and set of findings. I'm struck by your finding that the effects you observe generalize across younger and older adults. And I'm curious whether you think that this would be different if you looked at adolescents. So would you expect to see enhanced effects of stress and emotion on these kinds of cognitive processes that you're studying in adolescents?
So the question about adolescence, I'm afraid I don't have a strong grasp on the adolescent brain, but my intuition, I guess the laugh is nobody does, but my intuition would be, so it's interesting, in aging, the sort of focus has been, okay, there's prefrontal decline. Right, and there's been all sorts of focus on this, but it turns out that different areas of the prefrontal cortex are very different in their effects, how they're affected by aging. And the sort of ventromedial prefrontal cortex is relatively stable with age, whereas dorsolateral prefrontal cortex, lateral regions are more affected in aging. And the amygdala actually is relatively well maintained in aging as well. And anyone who studies adolescence, please let me know if this is a correct surmise, but I would guess, based on what know about brain and the development, that probably those regions are earlier to develop in adolescence than dorsolateral prefrontal cortex as well. So I would think that some of these things would show up pretty clearly in adolescence as well. But I would be happy to be argued with on this point, because I don't know the adolescent series of development so well, but my just from my guess is that I would think it would be pretty similar. Yeah.
I had a question, and it was similar to the question that Bob was asking. But when I was thinking about his question, you were looking at how there was sort of an implicit connotation. So you were saying that it was a negative image, that there was a negative emotional association, and that affected how they remembered it. And what he was talking about, and what I was also thinking about, which seems really relevant in practice, is that what we're often trying to do is get people to shift their emotional connotation of something, which is different than their memory of it. And I'm wondering if you've looked at that at all, if you're wanting somebody to remember something more positively or negatively.
Yeah, that's really interesting. How will that change? And is it harder if it's something that's really emotionally intense to go to something that's less intense? Yeah, it's interesting. How much is your emotional reaction to something part of your memory representation of that? And I would think that it is, to some, you're certainly remembering your emotional reactions from before as well. And it's, part of what gets evoked when you there's both the emotion that happens online, that you might think about something new about something, and then there's sort of the you have a remembered response that comes up as well. So I think that it's possible that there's some similar things that would go on in terms of trying to change your emotion reaction to this as well. And reappraisal is sort of one of those areas where you're trying to learn a new association, you're trying to develop something new to it. Is that going to be more difficult for something that was initially very strong? And I think this is a domain that is ripe for future research. How does emotion regulation change your memory representation over time? There's been a little bit of research on it, but how does it change? And then if you're how does it shift what it is that you're remembering, and when is it that you're most able to be, those reappraisals are most effective for future encounters with that thing? That's something really fascinating that I think I've been talking with someone in my lab about exploring that, because we don't know so well from the literature. Okay, I mean, there's a lot of interesting memory things that could be exploited here as to when it is that you can actually retrieve the initial memory and have the biggest change of it. And so that's really interesting from the reappraisal perspective, I think. Sure.
So I just wondered if you would talk a little bit about updating an age and kind of the specificities in that. So if I asked you, I've probably known you 15 years now, what are the things that you aren't as good at as you were when 15 years ago?
Not as good at.
Right.
I'm in competition with my past self here. Sorry.
Are you having any trouble doing that? Are you having any trouble? I mean, are you going to have any trouble answering that?
Apparently, yeah.
Well, I think you're weird. I think most people are pretty good at that. I think most people, unless they lose critical parts of the brain that are usually preserved in aging, do that self-updating pretty well. And as people age, they're often talking about the things that the things they're having trouble with, the things that don't come as easily. I think that's a part of life where there's lots of updating that goes on, and people do it quite well. Then there are these other kinds and in a way that's a kind of a reversal. But then there are these other areas where people are kind of stubborn and dogged, and they really can't seem to make the change. So, I was wondering if you had any thoughts about what kinds of things with aging are relatively easy to update, and what are the things that are really the stubborn points? Because that could have a lot of implications for behavior change.
This relates to something not related to my research, but that is about aging and thoughts about aging that is sort of a bugaboo for me. I get very frustrated when my friends say, "Oh, I'm falling apart, I'm getting older." And this really irritates me, because I think back, okay, I was in college, I was a runner, I had all sorts of injuries. I had foot injury, I had a knee injury, I had this. I never attributed it to age. I have injuries now. Why should I attribute them to age? I still run, I injure myself. And so that sort of thing, I feel like, is problematic in that people are updating and now attributing it to, okay, it's because I'm falling apart, when it might be. Certainly we have a lot of biological aging processes that go on, but people injure themselves at any age. The body's fallible. So if you're automatically attributing it to aging, then it's a problem, because you're not going to seek out treatment as much. You think that it's just something that can't be fixed. You're not going to do physical therapy. And so that's just completely unrelated to my talk, but it is sort of a button for me that being in the field of aging and seeing, people in middle age saying, "Oh, I'm just getting older, my knee's going out." Well, it's not necessarily because you're older. It could be just because you ramped up your running really fast, and that would have happened to you at age 20. So I think that in terms of just, what are you attributing it to, it's going to change the way how much you're trying to adapt and solve those problems, whether you attribute it to aging. So, your question was really about something a little bit different, which is, I think it was about how yourself, what things about yourself do you update, what things do you not?
Easily inaccurate.
Right.
And which ones do you really get stuck on?
Right. And it's not something we've done research on, but these sort of findings could lead you to think about, are the things that are really emotionally important for you that you might get stuck on and think that you're still the same way you were when you're not, actually. And how does this relate to those really fascinating data about how you compete with your past and self? So there's research showing, blanking on who it was who did these studies, but if you really care about a domain still, so let's say you were a violin player in high school and you still are a violin player and you're semi-professional, and so someone asks you, are you better now or are you better then? You'd be more likely to say you're better now because you still care about it. But let's say you were a football player in high school and you're no longer a football player. You ask, are you better now or then? You'd have no problem saying, oh, I was much better then. You're sort of basking in reflected glory. It's the same thing that people do with their friends. So if their friend is a football player and they're not a football player, they're delighted to say their friend is a wonderful football player. But if they're also a football player, they would say, oh no, maybe he's not so great. And so you do this with your past self as well, in terms of whether you are trying to compete with your past self. So I still, your question, a lot of domains I still care about. So I don't want to say that I'm less good runner. I don't want to say that I'm less good at, I was thinking, well, am I less good at remembering things? I don't want to say that. I still care about these things, So your question actually, when you were asking me this, I think I was, going to domains I care about. I don't want to say that my past self was better than my present self. And so that's something that, perhaps I'm not as good at updating because these are emotional things that I care about. But this is all really fascinating things that I don't have data on, but are really interesting. Yeah.
It'd be interesting to see the role of religion in that, because obviously that's the big deal. You're supposed to get better. And if you are religious, you might be able to do this updating more easily, and if you aren't, not. I don't know.
I don't understand. So you're religious, you're supposed to get better?
Well, that's the idea, is you sin and you seek forgiveness and you improve yourself and you get good enough to go to heaven. And if you don't, you go to hell. So if you really believe that, I think you're constantly doing an inventory of go to confession every week. I wonder what that does to your brain.
Okay, well, I guess. Thank you.